So today we are going to learn how to do instant segmentation based on Detectron2. So this would be our original image and this would be our segmented image. So this tutorial will be part of a playlist that I am teaching how to do instant segmentation. So first of all, we will install the environment. We will do it on Linux and on Windows as well. As you can see, it's based on CUDA 11.3. So we have to install PyTorch that support this CUDA 11.3. So we will start with Windows environment. If you have a Linux environment, jump directly to the relevant chapter. So let's start with creating our Conda environment. As you can see, it will be based on Python 3.9. Let's install the relevant libraries and let's activate this environment. Once again, I have a syntax error. Let's see, activate it. Great. As always, I will leave a link in the video description to an instruction file. Here it is. As you can see, this is the first step of the installation. As in Windows, you should install another software, which is the Visual Studio. It's free software, so don't forget to install it as well. Since I've already installed it, I will continue to the next step, and it's installing PyTorch. So this is the command for installing the PyTorch 11.13, and very important, in Windows only the CPU version works, so do not install the GPU version, only the CPU. The Detectron works well in Windows CPU and with Linux with a GPU. Next, we have to install several Python environments. So we will install the Ninja. And next, let's install PyYML version 5.1. Okay. Let's install the PyWin32. So as I mentioned earlier, all these commands will be in the instruction file in the link and within the video description. So this is OpenCV. Let's see, this is the instruction file. Now we have to install fvcore. So we will using a pip install git with the link to GitHub. Okay, finished. Next it's Cyton. Finished. What's next? Another one. All these necessary libraries are in Windows environment. In Linux, it's a different installation. Okay, now we have to install the Detectron2. So we have to choose a folder in our local machine. I will install it here under tutorials. So let's copy the command. It's a git clone with the full path to Detectron2. So this creates a new folder. Let's go inside this folder, Detectron2. And we are looking for set.py. Now we have to run this command, Python set.py build develop. So this would run, I believe, 2-3 minutes. So I will jump directly to the end. So now it's finished. Okay, now we have to open the VS Code, which the working directory should be our Detectron2. So this will be our, let's say, main directory. Now let's do the same thing on Linux. So I will use the Windows WSL2. As you can see, this is a Linux environment. Once again, let's create a new and fresh conda environment. Let's call it Detectron2 WSL, and the same Python version 3.9. Great. As you can see, it's working well, and now it's finished. Let's activate it. No, I have a syntax error. Let's fix it. Detectron2. Okay, now we are inside this environment. So this is our CUDA version 11.8. So now we have to install the relevant PyTorch according to your CUDA version. As you can see, I installed it already, and now we are creating a new folder named WSL, and inside this folder we are cloning the Detectron2. The same as we have done with the Windows environment. In the Windows environment we had installed more libraries. Here it's not relevant. So this is the command for the final installation. Let's wait a few more seconds. And it's done. So now let's run VS Code. And from here basically it's the same using Windows and Linux. I will continue with the Windows environment, but basically it's the same process. So now let's start coding. Along with the code I will leave this image, so you can use it as well. Copy it to the main folder, the main Detectron folder. And now let's create our new Python file. Let's call it simple instance segmentation.py. Let's replace our interpreter to our new conda environment. This is the one, and now we are using the relevant conda environment in our VS Code. So let's import torch. If everything works, you should see also the import Detectron in green, and we will also import numpy as np, os, and json. Let's also import OpenCV and random. We will use it later. Now here this model zoo, it's a specific functionality from Detectron2. It will help us with the segmentation. Also the default predictor is the engine module, and the getCFG function it will used for obtaining configuration for our model. The visual class from Detectron2 it's used to visual our predictions made by our model. So this image path should be our image. I have here a mistake. I will fix it later. So next we are importing our image, and let's change the scale to 30% since our image is too big. And using this command we will calculate a new width and height of our image based on the scale percentage provided earlier. So we are creating a tuple, which are the dimensions of the image. Tuple would be the width and the height. And next we will create a new image based on the OpenCV resize function. So the CV2 resize function is used to resize our image to our specific dimension using a specific interpolation. It's not really important this part. Then we are displaying our image using ImShow and waiting for a keystroke. So I have a syntax error. Basically, our image, we have to put the right path. So now it should work. Let's run it. Great. Here, this is our original image. Let's continue. So now we have to look for the right model. So this is the link for choosing our model. If we go to the Decathlon website, you can see this is for object detection. We are looking for segmentation, and this is for instance segmentation. As you can see, there are several models. Each one has a different inference time. Let's choose this one, R50FPN. So basically we are running an inference of instance segmentation. So this line creates a new configuration object using the getCFG function. And next we are going to merge the configuration setting from the maskr CNN model to the file retrieved using the model zoo getConfig file function, and it will be driven directly to the CFG inst object. And next, this function will set the weights of the model to the pre-trained model retrieved from the Detectron2 model zoo using the model zoo get checkpoints URL. And the next one, this CPU, it sets the device on which model we will run, CPU or GPU. This line might comment out if there is a CUDA available for a GPU acceleration. Since we are using Windows, this model works with CPU. On Unix, you can delete this line. The predictor, this is the instance of the default predictor class, is created within the configuration provided earlier. Then this is the predict using our function, and so the default predictor instance is used to make predictions on the input image, and the results are stored in the outputs variable. And next, the visual line. This line initializes the visual object with the input image, the metadata obtained from the training dataset associated with the configuration, and a scale factor of 1.0. And next we have to grab our image. So this should be in our out object. The visual arrow object is used to draw instance predictions obtained from the model's output, and the results is stored in the output variable. And then we are extracting the result image. The resulting image from the visualizer is retrieved and stored in an image variable after reversing the order of the color channels back from BGR to RGB. And now we are ready to display our predicted image along with the original image. We have to import another function, the metadata catalog. This is the relevant missing function. And let's run it. Great, as you can see, we have the original image and the segmented image. Thank you very much. I hope you enjoyed this tutorial. More instance segmentation based on other models will be published soon. Thank you very much.